Hello everyone.
Hello.
Good afternoon.
Good afternoon.
Is everyone okay after the King's Day?
Yes.
Everyone recovered?
Yeah.
Yeah. Okay, that's good. Okay, let's start our meeting about the nutrient recovery project. How is the progress of the project for everyone?
Yes, it's fine. Yeah.
Yep. We're working on the alternative research
Yeah. And the experiments.
and the experiments. Yesterday was the last experiment.
Yeah.
Yeah, I was there in the laboratory with Johan,
Mm.
and yeah, this time we did it differently from the other experiments. We preheated the sample
Mm-hmm.
before really starting the stripping process, and we also lowered a little bit more the pH to 10, but the results obtained, they were quite contradictory.
Yeah. Yeah, we can see.
And we also did the filtration for the sample before measuring the ammonia concentration by the Hachlang
Yeah.
tests.
Yeah. Achlang.
And yeah, the results after and before the filtration they were good, but after 1 hour of stripping and after 2 hours, yeah, they were a little bit weird. I don't know, maybe some mistakes were made during the dilution process, or I don't really know. This is happening quite often with us during the laboratory work. And yeah, until now, I think we have a really good idea of the key parameters for our experiment. For low timing experiments, like we are doing until now, for 2 or 3 hours of stripping, it's very clear that the key parameter is the temperature indeed, and also the pH.
pH also makes a
pH for sure,
difference,
but
yeah.
I think the temperature is even more important. Let's say like this.
Yeah.
Because from the last experiments, we saw that the pH of the sample in only half an hour went down more than 1 point, while the temperature was kept between like 75 and 70.
Yeah.
Which indicates a removal of ammonium.
Yeah, a really high
Basically,
removal.
high removal and pretty
pH
fast.
lowered 1 in half an hour, because in our experiment, the last one that we had, in 30 minutes the pH only decreased like 0.3 with the temperature at 60 degrees and the pH at 10
So that's from yesterday.
from yesterday.
Yeah.
So
Okay, that's a big difference.
that's a big difference.
And a temperature of 60 or
60 degrees,
60
yeah.
degrees.
Yeah.
And pH 10.
Huh.
And the other one that we had a way higher removal, the temperature was around 70 between 75, and the pH was 12, I think, or 11. It was 11, yeah, 11. So
Okay.
I think we have a pretty good idea of the key parameters until now. We just need to make sure that our results won't be contradictory, or if they
What do you
are,
mean
we
with
need
that?
to explain them.
Yeah.
Why we had this, we
Yeah.
need to explain clearly tomorrow in the presentation.
Yep.
So, do we need to take into account the other waste streams that are producing during the gasification process?
Actually, I think you could leave it out of the scope of the project. I can provide some data on it, and well, when you have some creative ideas, if you can combine those or things like that, you can look into it, but it's not primarily within the scope of the project.
It's not the main focus.
No. Because there are 3 streams coming out, which is this effluent, and there's a mineral stream with the inorganics, and there is a gas stream. So, well, when you think there's a good combination with the mineral stream, or I don't know, but well, just look at it, and when you think, well, it's a nice possibility, then you can investigate it further, but don't put too much time and effort into it. No?
Okay. Yeah.
around how many alternative techniques you think we should provide in our report?
What we normally do in wastewater treatment with ammonia-rich streams is like an Anamox principle. I don't know if you know it.
Is not, I think I've heard this before, Animals.
I have a report on different techniques on ammonia recovery, and in that report it's Anamox is used as a reference, so to say. So you can compare it with recovery of ammonia. So it might be nice to look at it as some kind of a reference for the stripping technology. And well, when you find other ways to handle this stream, let me know. Because well, I don't know. Then, but perhaps there are some other alternatives for these kind of streams, but I don't know. But well, it's not necessary to how do you say that? I think it's good to have some kind of a reference which is known, like this Anamox, and then the focus on stripping, because we expect that it's a good option, and then just look into if there are other options or not. But when there are no other options, it's also fine. So then you can just limit it to these options.
Well, now you guys know more or less how is this water phase produced. Now I'm gonna enter in the techniques to recover nitrogen from it. So our main technique, our main technology is the ANFR, which is air stripping process. And then there are many others. We have liquid gas liquid, vacuum distillation, struvite precipitation, chemical biological oxidation, and Anamox, which is not to recover and to remove. But all the other ones, they're focused on all recovery. Okay, the first one is the air stripping process. Well, as you can see here on the scheme, here the nitrogen-rich stream enters the stripping chamber, and beforehand the pH must be corrected, because you need to convert the ammonia, which is NH3, to NH4, which is a more volatile compound. So when you pump air into this stripper chamber, the ammonia is released as well with the water that is evaporating together, and it goes to this absorption chamber where you can wash it with acid, sulfuric acid or nitric acid, and then you can form this compound which can be used as fertilizer. So you form ammonium sulfate. And you need to make sure that the temperatures are around 60 and 90 degrees Celsius, and the pH is around between 10 and 12. And if you want to really reach highest efficiencies, as what we researched on, the highest efficiencies were achieved with 70 degrees Celsius and pH 12. So I believe they got around 90% of efficiency of recovery. And so there's a conversion of NH3 to NH4. NH4 is stripped from the nitrogen-rich stream, and then is led into this washing chamber and caught in acidic solution. And then the product can be used as a fertilizer. However, it must still be, the concentration must be regulated before you can really apply it on the soil as a fertilizer. Okay, and that. Pros and cons. You have a high recovery of nitrogen as ammonium, and it produces fertilizer. However, it also requires significant energy to be pumping air inside the stripping chamber, and also to mix in the tanks with acid. So it requires a significant energy demand, and also quite a lot of chemicals to control the pH and to wash in acid. So it's not really sustainable on this asset.